Alright, we're going to get going on this course by starting by talking about numbers. And each one of these sections, we're going to have a section number, and we'll have an I can statement that kind of defines what our objective is for the lesson. And then we'll have usually a warm-up or a starter or something like that. It may review some old concepts or just kind of get you thinking about the topic today with some background knowledge. So the I can statement for today is I can understand and define integers. So if you'll go ahead and write down everything that I write down on here, you'll have some notes that are filled in that you can go back and refer to. And I'll give you a hint today, every single one of the answers to the homework problems or the assignment are going to be covered in what we do for the notes. So what I want you to do first is I want you to think about what numbers you first learned how to count with. So that may have been before elementary school, you may have learned to count in preschool or maybe at home or something like that. Well, most people learn to count with these numbers. They start off with 1, then 2, then 3, then 4, 5, and so forth. Get up to 10. That's a big accomplishment when you're a little kid. Go count from 1 to 10. And for obvious reasons, these are called the counting numbers. And we kind of very naturally come across these. If we're going to count something, it makes sense to start by counting 1, then 2, and so forth. Well, we're going to talk about a more advanced set of numbers today. And what we're going to do first is if we put the number 0 in the group above, we get what are called the whole numbers. Whole numbers. So if we add 0 to this, so in other words, if we start at 0 and then go 0, 1, 2, 3, and so forth, those are called the whole numbers. So right here we've got counting numbers, and right here we've got the whole numbers. And these numbers are really easy to work with. They're very useful, but they do not work for everything. So what we're going to need is we're going to need to have a larger group of numbers that includes more numbers than just what we've got right here so that we can represent all different types of situations. And I'm going to give you an example to show what we're talking about. Is there a difference between having $5 and owing your friend $5? Well, clearly you'd want to be on the end of having $5, so that the answer is yeah, there's a big difference between the two of those. It's much better to have $5 than it is to owe $5. It feels different. It's a totally different situation. They both have a 5, but this 5 is much better to have than this 5 right here, because if you owe your friend money, you've got to pay them that money. So to help represent the difference in the example above, we need a symbol. And the symbol that mathematicians chose to represent owing money was a negative sign. So we're going to write the word negative in here. And a negative sign looks like this. It looks an awful lot like a minus sign. It's a little dash. But it indicates the sign of the number. And a negative sign in front of a number means opposite. So just like owing $5 is the opposite of having $5. If we did a negative for owing and just kind of left that alone there, that would be the number 5 that we're used to. And this is the opposite of 5. So just like owing $5 is the opposite of having $5, negative 5 is the exact opposite of 5. Now what I want you to notice is this 5 right here, there is no sign in front of that number. So if there's no sign in front of that number, then we assume that the number is positive. So just like all of these numbers that we've written up here, we'll assume that each one of those are like positive 1, positive 2, positive 3, and so forth. Okay? So we're going to take a look at this on a number line, and it's important to put 0 on a number line. It's always a good idea to put that there as a reference. So I'm going to slide this down and let's take a look at this. So I'm going to put 0 right here, and then we're going to put these two numbers on there. We're going to put the two numbers that we've been talking about, like having $5 would be represented with a positive 5. So here's 1, 2, 3, 4, 5. So I'm going to put a 5 right there. That's positive 5. And then negative 5 would go in the opposite direction. So this is the positive direction, and this is the negative direction. So we're going to go negative 1, negative 2, negative 3, negative 4, negative 5. So negative 5 would be right here. Okay, so there are the two numbers. Now you'll notice that the distance that they are from 0 is the same. We could count the number of little boxes here. Okay, so this is 1, 2, 3, 4, 5. and this is 1, 2, 3, 4, 5. So they're the same distance from 0, but they go in opposite directions. So the sign of the number represents its direction from 0. And that's really what that sign does. If it's got a positive sign in front of it or no sign in front of it, and we assume it's positive, then it's going to be to the right of 0. And if it's negative, like this one is right here, that means it's going to be to the left of 0. Now, the smaller a number it is, the farther it is to the left. And the bigger a number it is, the farther that it is to the right. Now, this is something you might have to think about for just a second, because we could put some numbers on here that seem like they're really big, but they may, depending on the sign, they may be one direction or the other. So we're going to represent this situation with money again. So we're going to represent each one of these with a positive or negative number, and then we're going to put it on the number line. So let's think about having $10. We're going to represent that with the number 10, and I'm going to put a dotted circle around that because we're going to use that again in just a second. We're going to say owing $100. That's going to be, owing would be represented with a negative, so that's going to be a negative 100. And then having $0, well, that's just going to be the number 0. The integer, the number that would represent that would be 0. Now we're going to need to think about this because I've got a number line right here. And remember, we're always going to put 0 in here, so I'm going to put 0 right there. So I've got that number represented. And then the positive numbers go here, and the negative numbers go here. So let's do that positive 10 right here. Now, if I were to go through and count 1, 2, 3, 4, and so forth, make each one of these little tick marks worth 1, I'd put 10 over here, but then I really wouldn't have the room for the negative 100. So you might want to stop and think about, how can we graph all 3 of these numbers on the same number line and still make this work out? So think about that for just a second. If you have to pause the video and think, you're welcome to. Well, the idea here is we're going to scale this axis a little bit differently. We're going to call this, we're going to count by 10. So this would be 10, this would be 20, this would be 30, and so forth. So 10 would be represented right here. So we've got 10 right there, and then this would be negative 10, negative 20, negative 30, negative 40, negative 50, negative 60, negative 70, negative 80, negative 90. Okay, good. We've got just enough room. So negative 100 is going to be right there. Now remember, up above we were talking about the fact that the smaller a number it is, the farther it is to the left, and the bigger a number it is, the farther it is to the right. Well, if we have a really big negative number, okay, if it's really far in that direction, we could also say that's a really small number. Like, for instance, negative 100 is smaller than 0 because it's further to the left on the number line. And that might take a little while to get used to, but that's one way that we can represent integers, is put them on a number line and compare relative sizes and things like that. Well, this brings up another concept, and that's the concept of absolute value. And you may have heard of absolute value, but I want to make sure that you understand what absolute value is. The absolute value of a number is its distance from 0. It's its distance from 0. So we're always talking about distance here when we're talking about absolute value. So since distance is always positive, that means the absolute value of a number is always positive. Now, some people will think of absolute value and they'll just say, oh, it just makes everything positive. And that's, to some extent, that's true. But the reason that's true is because it's always referring to a distance. Now, we use a special symbol when we're talking about absolute value, and that symbol looks like this. It looks like 2 vertical bars, and then it's got a number inside, and we've got an example of each of a couple of these. So I've got the absolute value of 4, and it says use the number line if necessary. So we're going to go ahead and do that. I'm going to put 0 right here. 4, the number 4 is right here. And the question here is, how far is that from 0? So we count these, 1, 2, 3, 4. Well, the answer to that is it's 4 units from 0, and that answer's got to be positive because it's a distance. Now, if we do one that's a little bit more interesting, like this one right here, like negative 8 would be negative 1, 2, 3, 4, 5, 6, 7, 8. So negative 8 would be right here. And then the question is, how far is that from 0? Let me put these dots on here so we've got those. Let's see, so we're 1, 2, 3, 4, 5, 6, 7, 8. 8 units from 0. Now, remember, we don't care which direction. We only care how far it is from 0. So we could count these tick marks this way. We could count it this way. It doesn't make any difference. So the answer to the question how far it is from 0 is 8. It's 8 units away from 0. Now, I'm going to change colors for this next one. We're going to put 6 on here. 6 is right here, and we'll go ahead and count. 1, 2, 3, 4, 5, 6. So the answer to that is 6. That's 6 units from 0. I'm going to do the same thing with this one. Negative 6 would be right here. And we're going to count. And again, it doesn't matter which way we count. We're just talking about the distance. 1, 2, 3, 4, 5, 6 units from 0. So the answer on both of those is 6. Okay, so we're in good shape there. And then let's do this last one. This last one is the absolute value of 0. Well, 0 is right on top of 0. So it's kind of a funny question. How far is 0 from 0? Well, since it's right on top of 0 and we don't have to go anywhere, then the answer to the absolute value of 0 is 0. Now, I want you to take a look at two of these in particular. I want you to take a look at those blue ones that we did, 6 and negative 6. So 6 and negative 6, negative 6 is right here, and 6 is right here. Those numbers have a special relationship. Since they are the same distance from 0, but they're in opposite directions, then we call those additive inverses. Okay? And what this means is if we put them together, we get 0. It means they kind of cancel each other out. They undo each other. So for example, if you had $6 and you owed somebody $6, when you get done paying them, you would have $0. Okay, these things would kind of undo each other. And when we talk about inverses, a lot of times we're going to talk about the fact that they undo each other. Okay, and that word's going to come up a whole bunch. You don't have to worry about it a bunch right now. But we'll just keep that in mind for this next example. So it says find the additive inverse of each of the following. So what we want to keep in mind is additive inverses are opposites of each other. They undo each other. They would add to make 0. So what would I add to 4 to make it a 0? Or what would I combine it with? Well, the opposite of this is negative 4. Those are additive inverses. They're exact opposites of each other. What's the opposite of negative 7? That would be positive 7. So what's the additive inverse of 6.2? Additive inverse of 6.2 is negative 6.2. It would be the opposite. What's the opposite of 0? Well, that's kind of an interesting question. 0 doesn't have an opposite. It's right on 0, so the additive inverse of that is 0. If we add those together, they would make 0. And then the additive inverse of this would be positive 594 because they're just opposites, and if we put those together, they'd cancel each other out and make 0. Okay, they'd add up to be 0. Now, with that in mind, let's talk specifically about what the integers are. We've got a bunch of different numbers here. And remember at the beginning we were talking about the counting numbers, and we were talking about whole numbers. And then we went through these examples where positive numbers aren't enough. We've got to include negative numbers. So let's talk about what the integers are. This isn't a technical definition. This isn't a mathematical definition of what integers are, but it works really well and it helps you remember all the different parts of integers. Integers are the positive and negative whole numbers including 0. So it's all the positive numbers, all the positive whole numbers, all the negative whole numbers, and 0. We throw that in there. Okay, so we want to go through this list right here, and we want to circle the numbers that are integers, and we want to give a reason why or why it is not an integer. So let's take 8. Well, is 8 a positive or negative whole number, including 0? Well, it's a positive whole number. So again, I'm going to put 0 right here, and then we're going to count over, and we're going to put 8 right there. Okay, so there's 8. That is an integer. Okay. 7.4. Now you'll notice that we've got the negative and a 7, but we've got this 0.4 here. That's 4/10. That's a part of a number, so that's not going to work. If I were to actually graph that, and this gets to be a little bit of a hassle. 1, 2, 3, 4, 5, 6, 7, 8. It would be about right there. Okay, that would be about where negative 7.4 is. You'll notice that it doesn't line up with a tick mark. Okay, let's go back to this one. Negative 4. Negative 4 definitely is an integer. So negative 1, 2, 3, 4. It's a negative whole number, so we're okay with that. Negative 4 is right there. 0 right there, that's the one we definitely include there, positive and negative whole numbers including 0, so we're going to say yes on that. If we had 1/2, that's a fraction, that's not a whole number for sure, so 1/2 would be about right there. Again, you'll notice that it's not in one of those tick marks, so that one's not okay, that one's not an integer. Then we've got 3.6, let's see, 1, 2, 3, 4. 3.6 would be somewhere in between, probably just a little bit closer to 4 than it is to 3. So that one's not an integer, doesn't land on one of those tick marks. It's not a whole number. And negative 5 and 5/7. So that one's going to be -5, -6. That one's probably going to be around right there, but that one's not going to work. Okay, so we'll cross each one of those off that I've got in red there. And then of course we've got the number 4. So the number 4 would be right here, right on one of those tick marks. It is a positive whole number, so we're going to include that. So the integers, and you've got to make sure you memorize this, the integers are the positive and negative whole numbers including 0, so make sure you get that down. So the last concept we want to talk about today is we want to talk about something called an additive identity. Now, mathematicians use some complicated words, but a lot of times the words they use give you a hint as to what they mean. So I want you to think about the phrase additive identity. So think about what word comes to mind, or what comes to mind when we say the word additive. Well, the root word right there is it, add. Okay, and then if you think about what your identity is, everybody has an identity, it's who they are. All right, so if we think of the additive and then identity, the identity is who, whoops, let me write that a little better, who or what you are. That's your identity. Well, if we put these together, then the additive identity is the number we add, so a number keeps its identity. In other words, so it stays the same. Identity. All right, so the question here is, what number do we add so the number stays the same? So stop and think about that for just a second. This would be something that you learned in elementary school, but you may not have used the same vocabulary. What number do we add so that the number gets to stay the same? Well, if you think about it, that number is 0. 0 is the additive identity, and I'll show you a couple of quick examples. 7 plus 0. This is cool when we learn how to multiply by 0 and add 0. The number just stays the same here. So we get a 7 on this one. There's the answer on that one. -42 plus something equals -42. Well, since it's keeping its identity, the number is staying the same. This has got to be a 0. If we use that same idea, we want to take a number, we want to add something, and we want it to stay the same. So we want the answer to be a 1, and clearly what we'd have to add would be a 0. And there we're starting with a -9.2, which again is not an integer, okay, but it's got to maintain its identity of -9.2, so we'd have to add 0. So there are some examples of using the additive identity. Now, if you were in class, we're going to do a money example. I've got some cards with some envelopes, and we'll talk about absolute value, talk about number lines, positive and negative whole numbers, including 0, all those sorts of things. And then I've got some practice problems for you today. And these practice problems, you can find almost every single answer in the notes above. So if you take a look at those and get those done, that would be awesome. Thank you very much.